Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy and today's topic is what is ADPI? ADPI stands for Air Diffusion Performance Index. ADPI is basically a way to statistically relate air temperature and velocity to occupant comfort. It's essentially a comfort index. You can measure the ADPI of a space or predict it with some basic information. Let's start with measurement. ASHRAE Standard 113, Method of Testing for Room Air Diffusion, defines the process in detail, but basically you start by taking temperature and velocity measurements throughout a room. Using these data points, you calculate the effective draft temperature of each of the points. The effective draft temperature is calculated with this equation. The effective draft temperature equals Tx minus Tc minus 0.07 times Vx minus 30. In this equation, Tx equals the temperature you measured. Tc is the control temperature or your set point, let's say 75 degrees. Vx is the velocity you measured. Okay, let's scoot this out of the way a little bit. Now let's say you measured a couple points. Say one point is 73 degrees and 50 feet per minute. So let's calculate the effective draft temperature of that. It would be 73 minus 77 minus 0.07 times 50 minus 30, and that equals minus 3.4. Let's say you have another point that's 75 degrees and 55 feet per minute. We calculate the effective draft temperature of that. You get 75 minus 75 minus 0.07 times 55 minus 30, and that equals minus 1.75. And so on. Let's make a little more room here. So your ADPI is the percentage of points that fall between -3 and +2. ASHRAE recommends an ADPI of 80 or greater, so if say 82% of your points fall between -3 and +2, you have an ADPI of 82. Okay, so let's draw a graph showing temperature and velocity. Across the bottom is temperature, and it's actually the differential temperature Tx minus Tc from our equation earlier. And up the side is velocity. We'll draw those in. Draw some lines so we can kind of see. Okay, now if you look at the point where the effective draft temperature would be -3 or up to +2, you can draw in these points and you can see it forms a parallelogram. Let me color it in a little bit so it's a little easier to see. So any point inside this parallelogram is an acceptable point for ADPI. The far right side is the +2, the left side is -3. One thing you can notice is down at the bottom, you could have 0 velocity as long as your temperature is between set point or about 4 degrees colder than set point, and this will still be acceptable. And on the top end of the scale, you can have a velocity of 70 as long as your temperature is at set point or up to about 4 degrees above set point. So this is great if you're looking at a test lab or you want to know the ADPI of a space after it's been built and installed and you can measure it, but it's much more helpful to know the ADPI during the design process. So years ago, Kansas State University developed, by grill or diffuser type, a correlation between the 50 foot per minute throw and the characteristic length to ADPI. T50 is the throw at 50 foot per minute, if you remember that from a previous podcast, and L is the characteristic length. So the characteristic length is from the center of a diffuser to a wall, or halfway between two diffusers. So then they created a graph that looks something like this, with T50 over L at the bottom and ADPI going up the side. Let's add the scale. and our ADPI is up this side. So the graph would look something like this. There'd be a curve. As the T50 over L changes, the ADPI would change. It's actually two curves, one for 20 BTU and one for 40. So let's draw a line across at ADPI. Anything over 80 is considered acceptable. And now if you draw this down, you can see that somewhere around 0.6 to about 1.5 would be the operating range of this diffuser where you kept your ADPI over 80. The actual chart they created has different types of diffusers and grills on it, but this gives you an idea. Here's some common GRD types, and there are T50 over L ranges for acceptable ADPI. A sidewall grill, like our 300 series, you want to have a T50 over L of about 1.3 to 2.0. A round air pattern diffuser, like our TMR, maybe 0.6 to 1.2, whereas a cross-flow pattern, like our TDC, is 1.0 to 2.0. And a slot diffuser has a wider range of 0.5 to 3.3. So now let's move this out of the way. Now you know, if you know the T50 and the room size, which gives you the characteristic length L, you can determine the optimal airflow range for acceptable ADPI in the space. This is also how software, like the Titus Teams GRD selection program, can tell you the ADPI of a diffuser. So that covers the basics of ADPI. Thanks for taking the time out with us.